Hi, this is Alex from devstories.eu, GeoDjango and PostGIS, episode 8 of 15. You might think every time you need to merge two polygons or find a spatial intersection, you have to write a query and wait for the database to return an answer. The reality is you can do complex spatial math right in your Python shell without ever touching a database connection. That is exactly what we cover today: the GEOS API and Pythonic geometry. A common misconception with GeoDjango is that PostGIS handles all the spatial heavy lifting. While PostGIS is incredibly powerful, the GEOS API allows you to perform geometric operations entirely in local memory. GEOS stands for Geometry Engine Open Source. It is a highly optimized C++ library, but GeoDjango gives you a powerful wrapper called the GEOS geometry object. This object lets you create, manipulate, and analyze geometries purely in Python. This is where it gets interesting. A GEOS geometry object does not feel like a clunky wrapper around a C library. It acts exactly like a native Python container. If you have a line string with 10 points, you can run the standard Python length function on it to see that it has 10 coordinates. You can iterate over a polygon with a standard for loop to extract its individual rings, or use an index to grab a specific point out of a multi-point geometry. They behave just like familiar lists or tuples of coordinates. The real power unlocks when you apply topological operations. Say you are building a logistics application and you have two overlapping delivery zones defined as GEOS polygons. You need to find the exact area where these two zones overlap. You do not need to save these zones to a model and run a database query. Instead, you can generate the overlap instantly in memory. First, you instantiate two GEOS geometry objects representing your delivery zones. Then you can simply call the intersection method on the first polygon, passing the second polygon as the argument. Because the API is deeply Pythonic, you can also just use the bitwise AND operator. You literally type polygon1 and ampersand and polygon2. This returns a brand new GEOS geometry object representing the exact overlapping shape. You have access to a full suite of these spatial operations. If you need to find the area covered by the first delivery zone but strictly outside the second, you use the difference method or the regular Python minus operator. If you want to merge them into one massive zone, you use the union method or the bitwise or pipe operator. You can even generate new shapes out of thin air. Calling the buffer method on a point geometry with a width argument instantly calculates and returns a polygon representing a perfect circle drawn around that point. Because everything relies on the underlying C++ engine, these calculations happen extremely fast. The key takeaway here is that the GEOS API gives you an independent, in-memory spatial engine, allowing you to validate geometries, calculate buffers, and find intersections before a single byte of data ever reaches your database. That is your lot for this one. Catch you next time.